Okay, so most time when students sees equation, most especially in physics or maybe mathematics, they find it very difficult assimilating such an equations, and it becomes very boring because they don't know the origin of the equation. So a teacher might just say a certain statement and then bring out an equation, and the student might be wondering where did this equation, where did it come from? Most of the equations that students actually seen in the class, they don't know where those equations came from, and it becomes a big problem when it comes to understanding maybe a simple concept in physics. So because not properly understanding where an equation is coming from is very disturbing, yeah, to students, because they don't really just depend on cramming those equations and then using it to solve problems. Because when you cram an equation and you don't know the source of such equations, it becomes a very big problem, because understanding the origin of that equation will give you an idea how to use it and when to use it. So that is exactly what we are trying to do here, using critical thinking, most especially when you are trying to solve problems. Now, let us look at this equation. So where is this equation coming from? Do you think about that? Yes, we know that V is initial final velocity, U is initial velocity, A is what? Acceleration, and T is what? Time. We know that. But how did we get to these formulas? Because these formulas are just tools for solving problems. So they didn't just come from nowhere. Somebody just used it as an assistant so that we can use it to solve problems. So that doesn't mean that if we start memorizing these things, we won't understand what we are doing until we get back to the what, to the origin of these things, so we can understand why we actually use formula in the first place. Because one can actually solve problems without using just a physical formula like this, because you understand what you are doing. So most time you don't need to use a particular formula, though you can actually bring it out in terms of formula, but that doesn't mean you must have a written formula for you to solve problems. Now, in this question, so this equation is actually coming from the definition of acceleration, so which is the change of velocity per unit time, or the increase in velocity per unit time. So when we are talking about increase in velocity, so what are we trying to talk about here? We are just trying to say that maybe speed or a pace, like we can actually say it in a layman's language. You understand? So when we change pace, maybe from a certain speed to another speed, or from standing to now running, so we changed pace. So that's what the speed is talking about. So we increased speed from walking now to running. So that means we can actually use, when we were walking, we can just use it as the initial speed, and then when we start running, then we now take it to be the final speed. So that's exactly what we're saying. So we are just defining acceleration as the change in speed or change in a pace, as the case may be. So if the final pace is represented with this, and then the initial pace is represented with u. So the change in pace is just the final minus what? Minus the initial all over the time. So because there is always a time for such a change. So that is how we got this equation. And then when we now cross multiply this, we can now see that 1 times v is v, and 1 times minus u is minus u, and a times t is what? At. So, and then we want to make the final velocity the subject. So we just do v is equal to, moving this to the right, becomes what? U plus what? At. And that's how we got the equation. So the understanding of how we got these equations are very important, and they are very critical. So when we understand how we got the equation, there is no point cramming anything, because already we know what we are doing. And that's how we solve problems.